Hello, let's look into today's problem. It says count the number of covered buildings. It says you're given a positive integer and representing an end-to-end city. Okay, you are also given a two-dimensional grid buildings where buildings of I is x comma y denotes a unique building located at okay, so they are giving the coordinates of different buildings. Okay, a building is covered if there is at least one building in all four directions, left, right. Okay, return the number of covered buildings. Okay. Okay, so I should basically find the number of buildings which have at least one building on top, down, left, right. Okay, so how can I go about this is, so this is what I'm thinking of, right? If I take okay, if I consider only the buildings at x equals 2 and then count all the y coordinates present at that and count all the buildings present with fixed x coordinate. So when my x coordinate is 2, I have three buildings with different y coordinates. Okay, and one thing I'm sure of is the minimum and the maximum of these y coordinates cannot be the answer, because they are in the extremes and they cannot have buildings on up or down, so that way. Okay, that is one thing. Okay, I sort out the top down. How will I check for the left, right? Okay, for each building I check if there is a building to the left of this building and there is a building to the right of this building. So I check, see, for this y coordinate, what are the x coordinates of different buildings. Like I fix y and then find the x coordinates and then check. I can also check only the extremes, right? See, like if the minimum of this fixed y coordinate, like so the minimum of this fixed y coordinate should be lesser than my current building, and the maximum should be greater than my building. Yeah, that would work, right? Like let me explain it over here. So if like okay, let me draw a 3x3 grid. Okay, so this is that grid. Okay, how do I change the color here? Okay, cool. So this is one building, this is one building, this is one building, this is one building. Okay, this is one building. So one thing what I can take note of is I consider this entire y coordinate. So this cannot be my answer and this also cannot be my answer, but any of these two can help in giving other the answer. For example, to make this as my answer, or let's say there is one more building here, to make this as my answer I want to take the help of this, right? So that's what I'm thinking of, like so it's basically like for this x coordinate, these are the x coordinates, these are the y coordinates. I fix this x coordinate over here, and for this x I group all the buildings with different y coordinates. So y would be 1 2 3. So I can have a dictionary which says if this is my x, at this x I have 1 at 2. Okay, and then when x is 2, at this x I have 1 2 3. Okay, So now what I do is I take anyone. I take the groupings of and also I should also group the y's, right? So y would be 1 I have here, and this would be 2, and there would be one more hash map for this 2. It would be 1 2 3, right? And there is one more hash map for 3. It would be 2 and 3, because for this. Okay, okay, cool. So okay, this looks a bit shabby. Never mind. So while I have this, I'll fix x. Okay. Okay, then what can I do? So if I fix x, like if I take x as 2, okay, so it would be 1 2 3, right? 1 2 and 3. I'll leave all the alpha sorted, and then I leave the first and the last element. The only element I take is from the second element to the last second element, because the extremes cannot be the answer. So here I consider 2, and then I get all the buildings present. I get all the x coordinates of those buildings present when y is 2. So I get 1 and 3. Okay, so I basically get this. I map this to this. Okay, so once I get this, what can I do? Okay, I check if the minimum is lesser than this and maximum is greater than this. If that is the answer, then if this both conditions satisfies, then that would be my answer. Okay, so let's, if I think about this problem, so see here, there is only 2 elements, so I basically won't be traversing through anywhere, right? So that won't be counted. If there would have been one more here, then I would have gone, I would have checked for this. Okay, so this is 3, right? When x is 3, I have 1 2 3, and then I leave 1 and 3. I check only for 2, come here, but the minimum is obviously smaller than 3, but the maximum is not greater than 3, so that won't be counted, right? Yeah, I think that would work. Let's go ahead and code it up. I'll have x groups first. Default dict list, and then I'll have y groups. Default dict list. Okay, and then I traverse through x comma y in buildings. Okay, x groups of x dot append y, right? Dot append y. Okay, and then y groups of y dot append x. Okay, at the same time, if I now I'm considering x, right? So I'll sort all the elements at x. So for x comma x list in x groups dot items, x underscore list dot sort. Okay, and then x underscore groups of x would be x underscore list. Okay, I have sorted everything now. Now my answer would be 0, and then again I traverse through for x comma, this would be a list of y, right? Yeah, so okay, I think would be good if I name it as y list, because that consists of all y in y elements in x underscore groups dot items. Okay, now my y list is sorted. I traverse only from second element to the last second, right? So for I in range, okay, let's keep len y list as len of y list. For I in range, len of y list minus 1, because Okay, I should also give it as 1, right? Because I'm leaving the first element. So here comes the thing. Okay, now I check if the x list. X list would be y groups of what? Would be y groups of y list of I. Okay, this would be my x list. If now I check if my minimum of x list is lesser than is lesser than what? My x, for this x, right? And maximum of x list is greater than x. And I should also check for one more condition where okay, I think where only these two conditions that I was taking care of. Okay, check for this and this and then this and this. Okay, yeah, I think these are only the two conditions. If this is the case, then answer would be 1. Otherwise I would return x. I don't know. Okay, let me run it once and check. Okay, it runs. Okay, let's submit it. Okay, it did submit. So yeah, that was today's problem of the day. Wait, okay. Okay, I was also thinking of what if there is same y. Does it say in the constraints all coordinates of buildings are unique? Cool, then I don't think it does matter. Like if there is the same y and the same x, it cannot be possible, so which means that it is unique. So yeah, I think this is the answer. Yeah, this is the answer. This looks good. Okay, now let's check the time complexity of this here. Worst case time complexity would be n into n log n is what I'm thinking of, because let's say if every x is unique and every y is unique, I come here and then sort it in O of n log n. I don't know, man. I'm a bit confused. Yeah, I feel this is the time complexity right over here. This is something that's increasing because see, you have everything as unique. Okay, so for a one single x you have multiple I, so that would be O of n into n log n. Yeah, this is what I'm thinking. I think it's clear. Okay, not fully sure of it as well. Yeah, I think it's of n log n. Let me know if this is wrong. So yeah, that was pretty much it for today's problem of the day. Thank you. Bye.